Section 5.9, or last section of the summer semester here. All right, so we're going to evaluate with U substitution now. The only difference is before we said let's do without limits of integration U substitution. Now we're going to see how we handle with limits of integration. Now I'm going to show you two methods, method 1 and method 2. The only reason I'm showing you two methods here is because I do not know what your physics or your engineering professor or whatever is going to use, method 1 or method 2. In this way you'll be covered no matter what they do. All right, method 1. Start out with your original integral. All right, so we start out with this. And then let's do a U substitution. So let's let U equal to 4x minus 2. So the derivative of U with respect to x will be what? 4. Then I can say du is equal to 4 dx. And I can multiply both sides by 1/4. So 1/4 du is equal to dx. So what I'll do is I'll come over here and write the integral. Instead of 4x minus 2, we're calling that what? U to the third. Instead of dx, we're calling that what? 1/4 du. Now for method 1 here, I'm going to lose these limits of integration for a little while. Then I'm going to reinsert them later. All right, this 1/4 multiplied in the integrand can be pulled out to the front, and we can call that 1/4 times the integral of u cubed du, which we can say is 1/4 times u to the 4th over 4. Or I could say, okay, this 4 gets multiplied by that 4, so that's 1/16 u to the 4th. So 1/16 u to the 4th like that. Now what I want to do is I want to back substitute that u of 4x minus 2. So 1/16, instead of u to the 4th, I'm going to put in 4x minus 2 to the 4th. And at this point, whenever I back substitute, I'm going to throw back in my original limits of integration, which were from 1 to 2. 1 to 2. Now proceed as usual. So you have 1/16 times 4 times 5 minus, 4 times 2 minus 2, 4 times 2 minus 2, minus 4 times 1, 4 times 1 minus 2. All right, so that gives you what? 1/16, and what is that? 8. Well, what do I need to do here? I need to raise that to the 4th, right? And I need to raise that to the 4th as well. So put a 4 there and there. All right, so what is that? That's 8. 8 minus 2 is what? 6 to the 4th. Minus, what is that? 2 to the 4th? All right, so calculate that, minus, calculate that, then multiply by 1/16 and so forth. And I got 80 whenever I did this earlier. I got 80. Make sure you get 80 there, okay? All right, that is method what? 1. Let's look at this problem using method 2. Method 2. All right, here's what we're going to do for method 2. We're going to start this thing with my original problem, the integral from 1 to 2 of 4x minus 2 cubed and dx, right? Well, we already did a u substitution here, so I don't need to redo that. So I'm going to say, here's my integral of u cubed, but instead of dx, we're going to say 1/4 du, right? Now for method 2, what you want to do is you want to put some new limits of integration here. All right, 1 and 2 were my limits of integration whenever this integrand was in terms of x. But what about when the integrand is in terms of u? I need to change these limits of integration. So here's how I change these limits of integration. I say, okay, when x is equal to 1, my lower limit of integration, when x is equal to 1, I sub it in right here. I say that u will be equal to 4 times 1 minus 2, or u will be equal to 2. So when x is 1, u will be 2, so my new lower limit of integration now will be 2 right here. How about my upper limit of integration? It was 2. So when x is equal to 2, u then will be what? 4 times 2 minus 2. So that's what? 8 minus 2, or what? 6. So my old limit of integration 2 turned into 6. All right, now let's pull the 1/4 to the front. So 1/4 times the integral from 2 to 6 of u cubed du. So that's 1/4. Now let's evaluate this integral. That's u to the 4th over 4. Now what I'm going to do, instead of back substituting this in terms of x, I already changed my limits of integration. So I'm going to keep it in terms of u and evaluate it from 2 to 6. So in method 2, we do not turn this back in terms of x because we already changed my limits of integration for u. So we keep that in terms of u. So that's going to be 1/4 times, what do I have here? 6 to the 4th over 4 minus, what? 2 to the 4th over 4. Minus 6. I'm sorry, minus 2 to the 4th over 4. So if you go ahead and you go through the process of calculating this, you're going to get 80 again. You're going to get 80 again. So method 1, method 2, learn how to do both methods here. Is one better than the other? Not for every single problem. Sometimes method 1 works better for a particular problem. Sometimes method 2 works better for another problem. I just want y'all to know how to do both ways so you'll be able to follow your teacher next semester. All right, part B. Suppose we have the integral from the natural log of 4 to the natural log of 4 of e to the x over e to the x plus 8, and then we have a dx here, okay? Let's do method 1. Method 1. So what is method 1 summed up? You're going to lose your limits of integration for a little while, back substitute in terms of x, and then throw back in your limits of integration. So let's do so. So we have the integral from negative natural log of 4 to natural log of 4 of e to the x over e to the x plus 8 dx. All right, let's do a u substitution. I'm going to pick u is equal to e to the x plus 8. E to the x plus 8. So du over dx will be e to the x, and du will equal to e to the x dx. So right here, we're going to have the integral. We're going to lose our limits of integration. We're going to say, well, let me do a rewrite real quick before I lose my limits of integration. Let me do a rewrite. I like to write this as 1 over e to the x plus 8 times e to the x dx. In other words, I'm factoring this e to the x to the side. And the reason why I do that is because I want this exact thing right here. All right, so I'm going to lose my limits of integration for a little while. I'm going to say that's 1 over u times, what's e to the x dx? That's just du, right? Well, I have a formula for this. This is the natural log of the absolute value of u. Now for method 1, I need to turn this back in terms of x. So I'm going to write the natural log of the absolute value of e to the x plus 8. And what am I going to do? I'm going to reinsert my limits of integration that I had from negative natural log of 4 to natural log of 4 like this. All right, well, before I end up putting in natural log of 4 and subtracting negative natural log of 4 from this, I'm going to look at e to the x. Will e to the x ever be negative? No. Raise it to a positive number, that's just basically 2.71 to a positive, right? Raise it to a negative number, like e to the negative 3. What is that? Just 1 over e cubed, which is 1 over about 2.7, which is still a what? Positive number, right? So this won't ever be negative. In fact, it'll be what? Positive, right? And if I take a positive and add 8 to it, it's still positive, right? So what is the absolute value of a positive? The same thing as what's in the absolute value. So I can do a rewrite and drop my absolute value. Say this goes from negative natural log of 4 to natural log of 4. Now let's say this is the natural log of e raised to the natural log of 4 plus 8 minus this stuff evaluated at negative natural log of 4. So e to negative natural log of 4 plus 8. Let's see, so what do I get here? I get natural log. What is e raised to the natural log of 4? Just 4, right? Plus 8. Remember, this base is the same as that base up there. Drop all that. Now over here, I'm going to do a rewrite. That's like a negative 1 multiplied in front, right? Remember that property of logarithm says I can bring the negative 1 to the exponent of my argument? So I can write that as e to the natural log of 4 to the negative 1 here, plus 8. So that gives me the natural log of 12 minus the natural log of, what does this turn into? 4 to the negative 1 plus 8. So here we have natural log of 12 minus natural log of 1/4 plus 8. Or we can say natural log of 12 minus the natural log of, what do I get whenever I add that stuff up? And that's what, 32 over 4 plus 1 over 4, so 33 over 4 like that. Now that would be fine. When you click on show answer on Wiley Plus, they're going to do this. They're going to say, I have 2 natural logs being subtracted, so I'm going to write natural log of this argument, 12, over this argument, 33 over 4, which they're going to multiply by the reciprocal here and change this into the natural log of 12 times 4 over 33, which they're going to say is the natural log of, divide these both by 3, and what do you get? You get 11 there, and you get what? 4 there. So I'm going to say natural log of 16 over 11. Either one of those is fine, though. All right, let's look at method 2 now. We just did this with method 1. Okay, think about what is method 2. Method 2 is what? Do to use substitution. Change your limits of integration, but do not back substitute. Let's see. So if I want to do method 2, you're going to have this. I'm going to have the integral from negative natural log of 4 to natural log of 4 of e to the x over e to the x plus 8 dx. All right, so we're going to rewrite this as 1 over e to the x plus 8 e to the x dx from negative natural log of 4 to natural log of 4. Remember, I like this to be out there. So we have the integral of 1 over u. E to the x dx is du. But what are we going to do? We're going to put some new limits of integration here, okay? So when x is equal to negative natural log of 4, what are we going to have? Well, let's see. U will be equal to e to the negative natural log of 4 plus 8. Or I can say u is equal to e to the natural log of 4 to the negative 1 plus 8. Or u is equal to 4 to the negative 1 plus 8, which means 1/4 plus 8. And what did we say a little while ago whenever we did this problem? We said that that's what? 33 over 4, right? So when our old limit of integration was negative natural log of 4, what's my new limit of integration for my lower one? 33 over 4, right? What's my new upper limit of integration going to be here? Let's see. When x is equal to the natural log of 4, when x is equal to the natural log of 4, what is u going to be? U is equal to e to the natural log of 4 plus 8. Or u is equal to 4 plus 8, or u is equal to 12, right? So my new upper limit of integration is 12. All right, let's go ahead and take this integral here. So what do I have? The natural log of the absolute value of u, and where do I want to run it from? 33 over 4 to 12. Okay, let's see what we get now whenever we do the math here. This is going to be the natural log of the absolute value of 12 minus the natural log of the absolute value of 33 over 4, right? Well, absolute value of 12 is just 12. The absolute value of 33/4 is just 33/4 without absolute values. This would be fine. What's the other way we said we could write this? Natural log of 12 divided by 33 over 4, which is natural log of 12 times 4 over 33, which we said was the natural log of what? 16 over 11. Natural log of 16 over 11. As you can see, you get the same thing again. All right, this next example, I'll tell you what, let's just do method 2, okay? I'm probably bored now doing both methods. Next example, let's just do method 2. So we're going to have the integral from 6 to 15 of x square root of 10 plus x dx. Now I'm going to use method 2. All right, let's do a u substitution. I'm going to pick u to be 10 plus x. So du over dx is equal to just 1, right? So that means du will be what? Dx, right? So I'm going to have the integral of x, whatever x is, times the square root of, what is this part? That part's u. Instead of dx, I'm going to call that du. But what do I put in terms of x? Well, the way you find that is you just solve this for x. So u minus 10 is equal to x, right? So instead of x right here, I'm going to put u minus 10. Now, if we're doing method 2, let's change my limits of integration. Let's just do this in our head this time. My lower limit's 6, x is 6. So 10 plus 6 will give me 16 for a new lower limit. How about my upper limit? It was 15, but now what is it? 10 plus 15 or what? 25. So this gives me the integral from 16 to 25 of u minus 10. Instead of square root of u, I could call that u to the 1/2 du. Now for the next step, I'm going to distribute this u to the 1/2. And we'll get the integral from 16 to 25 of u to the 1 plus 1/2, or 3/2, minus 10u to the 1/2 du. Now let's go ahead and take an antiderivative here. So if we go ahead and we take an antiderivative here, what are we going to have? We're going to have u to the 5/2 times 2/5 minus 10 times u to the 3/2 times 2/3, and we're going to run that from what to what? 16 to what? 25. All right, let me play around with this, maybe factor some stuff out here to make it easier on myself. So I'm going to say this is equal to, let's see, let me clean it up first. We have 2/5 u to the 5/2 minus, could I call that 20/3? So 10 times 2/3 is 20/3. U to the 3/2 from 16 to 25. Now let's go ahead, I guess, factor. It's not really going to make it any easier if I factor 2 out. I might as well just stick with this. So I have 2/5 times u to the 5/2. And I'm going to substitute in 25 here. Minus 20/3 times u to the 3/2, which is 25 to the 3/2. I don't need this. Minus this stuff here, evaluated at 16. So that's 2/5 times 16 to the 5/2 minus 20/3 times 16 to the 3/2. All right, so what do we get here? We get 2/5. That's the square root of 25 raised to the 5th, right? Square root of 25 is 5 raised to the 5th. Minus 20/3. That's the square root of 25, which is 5 raised to the 3rd. Minus, what does this give me? 2/5 times what? That's the square root of 16, which is what? 4 raised to the 5th. Minus 20/3 right here. And what's the square root of 16 again? 4 raised to the what? 3rd. All right, let's see what we have. Could I do this right here just to make the math a little easier? Call that 5 to the 1st. And so, okay, 5 to the 1st divides out with one of these. So I really have 5 to the 4th now. So I have 2 times 5 to the 4th. Minus 20/3 times, what's 5 cubed? 125. Minus 2/5 times 4 to the 5th. What is that? 4 times 4 is 16 times 4 is what? 64. 64 times another 4 will give me what? 256 times another 4 will give me what? 1024. minus 20 thirds times what's 4 cubed? Well, we just said 4 cubed is what? 64? All right, at this point, just go ahead and throw all this in your calculator and so forth. And if you get a decimal, hit math enter, and you get 6506 over 15 for this one. 6506 over 15. Let me see if there's something else we need to go over here. Yeah, let's do one more. Let's do one more. Yeah, keep checking my watch because I got a Zoom meeting coming up. That's why. I can't believe during this recording there hasn't been some kind of siren pass by. Usually that happens every time. All right, this next example says integrate by changing the limits of integration. By changing the limits of integration, so what they're going to want us to do is use method 2. Let's see. We have this pretty little problem, right? All right, so let's use the u substitution. I'm going to let u equal to what's under the radical, x squared plus 4x plus 3. So that means du over dx is equal to 2x plus 4. Or we could say du is equal to 2x plus 4 dx, right? Now I'm going to do a rewrite here. I'm going to say this is the integral from 1 to 3 of 1 over the square root of x squared plus 4x plus 3. And bring this out to the side and have this as x plus 2 dx. So let's see what we have here. We're going to have the integral of 1 over the square root of, what did I let that stuff be? Let that stuff be u. All right, what about this part? X plus 2 dx. I don't have that exactly right here, right? But could I do this? Could I say, what if I factor 2 out of this? Then I get x plus 2 dx. And to get this part exactly like that, just divide both sides by 2 or multiply by half. So 1/2 du is equal to x plus 2 dx. So what is x plus 2 dx? 1/2 du. Pull the half to the outside. Take the integral of 1 over square root of u du. Let's insert our limits of integration though here and here. When x was 1, plug it in here. What do I have? 1 squared plus 4 plus 3. What does that give me? 8. So my new lower limit of integration went to 8. How about my upper limit of integration? How about when x is 3? We have 3 squared plus 4 times 3 plus 3. Plus 3. So we get 9 plus 12 plus 3. Okay. 9 plus 3 gives me 12, plus 12 is 24, right? The new upper limit of integration is 24. So I'm going to put 24 here as well, and 8 down there. All right, so we have what f? We have the integral from 8 to 24. Isn't this u to the 1/2 at the bottom? So if I bring it up top, it's really u to the negative 1/2 du. Well, let's go ahead and evaluate. So I have 1/2 out front. I have 1/2 out front. What's the integral of u to the negative 1/2? U to the positive 1/2 over 1/2, or I could say multiply by the reciprocal 2. From what to what? 8 to 24, right? Well, 1/2 times 2 is just 1. So really I have u to the 1/2 from 8 to 24. So what does that give me? 24 to the 1/2 minus 8 to the 1/2. Well, isn't that really the square root of 24 minus the square root of 8? How about 24? I can break that down into 4 times 6, right? And 8 I can break down into 4 times 2. So what's the square root of 4? 2 comes to the outside, 6 stays under the radical, minus square root of 4 is 2 comes to the outside, and 2 stays under the radical. There we go. There is my integral by using what? Method 2. Good luck, folks.